Welcome back. In this video, we will prove cosine rule. So what is cosine rule? Cosine rule says that a squared equal to b squared plus c squared minus 2bc cos a. Right? So let's prove this one. In order to prove cosine rule, we need to split this triangle into two right angle triangle. Right, here we go. Now we have right angle triangle so that we can use trigonometric ratios. So SOHCAHTOA, if we use SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. So let me write this down. Sine theta is opposite over hypotenuse, and we need to make opposite subject, right? So the opposite is hypotenuse times sine theta. Similarly, cosine is adjacent over hypotenuse, so cos theta is adjacent over hypotenuse, right? So again, we need to make adjacent subject, so adjacent equal hypotenuse times cos theta. Right, so let me put a box. We need to use these equations to prove this one. So opposite equal hypotenuse times sine theta, adjacent equal hypotenuse times cos theta. Right, so if we focus on the blue triangle, this is opposite, right, to the angle A, and this is adjacent, right? According to this formula, opposite is hypotenuse times sine theta. Hypotenuse is B, therefore opposite equal B times sine A, and adjacent equal, adjacent is B times cos A, so angle is same. Now what we are going to do is we are going to focus on this triangle, this right angle triangle. This is the angle of interest, right? B. Opposite of this angle is this one, and adjacent is this one, right? So we know this side, which is equal to A, and this side, the length of this side is equal to B sine A. And what about this one? We know, according to our notation, from here to all the way to this end, this length is equal to C, right? However, we now prove that this length from here to here is equal to B cos A. Therefore, this small length is going to be C minus B cos A. So let me write this down. Is equal to small c minus B cos A. If we focus on this triangle, according to Pythagoras theorem, we know square of this one is square equal to square of this, which is B dot sine A, plus square of this one, square of this side, which is C minus B cos A square. So let me expand this one. So B sine A square is equal to B squared sine squared A. Right. So let me remind you that sine A squared, instead of writing like this, we can write in trigonometry. Instead of writing this one, we can write A. So this is kind of a shorthand notation. Okay, so remember this. So if we come back to this one, B squared sine squared A, plus if we expand this would be C squared, right, minus 2 times C times B cos A, and squaring the second one would give you plus B squared cos squared A. Okay, so what I am going to do now is I am going to combine this one and this one together. So because B squared is common, so I'm going to write B squared. If I take B squared out, sine squared A plus cos squared A, and I'm going to write the rest of them as it is, plus C squared minus 2BC cos A. What is this? Sine squared theta plus cos squared theta is equal to 1. This is one of the identities that we will learn shortly. Therefore, this is equal to 1. Let me write this one here. So A squared now equal B squared times 1 is B squared plus C squared minus 2BC cos A. Here we go. Now we have the proof for the cosine rule. Thank you. Please go to next video.